So, ayan po, gawin po tayo ng isang word problem. You are running a concession stand at a basketball game. You are selling hot dogs and sodas. The cost of 3 hot dogs minus a single hot dog is $5. 4 sodas and 2 hot dogs will cost $7. Determine the price of a single hot dog and 1 soda. So, given yung x is equals to soda and y is equals to hot dog. So, gagamit po tayo ng linear equation para po mahanap po natin yung value ng x and y. So, yun po ang mga nang-araw po sa ating lahat. So, masasolve po tayo ngayon ng isang simultaneous linear equation gamit po ang Jupyter Notebook. So, Python programming. Yan po, simultaneous linear equations. So, maglalagay tayo ng dalawang equations. So, bali to ano siya. So, it's given to equations. Um, 3y minus x is equals to 5. So, yun yung unang equation. 3y minus x is 5. And 4x plus 2y is equals to 7. So, yan po ang dalawang equations. 3y minus x and 5 equals 5 and 4x plus 2y equals to 7. So, hanapin po natin yung y and x variables. So, ang una po natin gagawin is import ang phi as np. Next naman po, from SciPy, import line alg or linear algebra. So, SciPy paggagamitin natin. So, solve na yun ang problem na to. So, same po tayo, E is equals to np dot array. So, bracket, parenthesis, so bracket, ang una din is negative 1 kasi negative x, so negative 1. Then 3 sa unang equations. Next naman po is 4 and 2. So, yan po yung mga constants po sa katabi po ng variable. So, next naman po is b. Mali. So, b is equals to np.array. Yan naman po yung mga constants po na nasa labas. So, yan po yung 5 and 7.
Good day. Now we will going to solve for the differentiation in application of differential calculus using Python. Here is the problem. C gives the cost in dollar to shred W pounds of confidential documents of a company. Given the function C of W is equals to 0.001 times W raised to 3 minus 0.15 times W raised to 2 plus 7.5 times W. What is the instantaneous rate of change of the cost when the weight of the documents is 10 pounds? First, we we're going to put import simpy as sp. Next is w equals sp symbol w. Next, para malaman natin yung derivative ng function na yun, print natin sp differential, ilagay natin yung function 0.001 times w raised to 3 minus 0.15 times w raised to 2 plus 7.5 times w. Yan. Print natin. Run. Hintay lang. Yan. Ito na yung derivative ng function. Next is, hanapin na natin yung sa condition na kung 10 pounds daw yung weight ng document. From import natin yung derivative. Next, f of w equals return. I-copy na lang natin dito yung function. Tapos i-print na natin para malaman natin yung sagot. Derivative yung 10 ilagay natin sa condition. Check natin kung may na ano ba. W i-run na natin to. May namali tayo dito sa yan na. And that's all. The answer is 4.8, which is pag i-solve mo siya analytically, maglalabas na naman yung 4.8. Thank you.
Hello, yung topic natin is engineering problem about integration. Yung problem is find the area under the curve of f of x equals x squared for x is from 0 to 3. Yung magiging graph niyan is ito. So, pantay lang siya sa x squared f of x equals x squared. Yung susunod natin gagawin dyan is i-integrate muna natin nang hindi gumagamit ng Python. So, ganito natin siya integrate. X squared equals integration from 0 to 3 of x squared dx gamit ang addition rule. Add lang natin ng 1 yung 2. So, x squared plus 1 over 2 plus 1 plus c. So, yung kalalabasan yan is x cubed over 3 plus c. Tapos yung mga binigay na x, yung 0 pati 3. So, yung mauna dyan is magiging 3 raised to 3 over 3 minus 0 raised to 3 over 3. So, x squared equals so yung kalalabasan is 9. So sa Python, kailangan 9 din yung lumabas na sagot natin. So yung sa problem dito, yung unang gagawin natin dito sa Python is una, mag-import tayo. Import simply as sp. Sunod, gagawa tayo ng panibagong symbol. So, x equals sp dot symbol ng x na siya hinahanap. So, susunod natin gagawin is mag-integrate na tayo. So, sp dot integrate so, yung dalawang binigay na x is gagamitin natin dito. X squared. So, dahil hindi pag niran mo, hindi mababasa ng Python yung x squared na na number is yung gagamitin na lang natin is asterisk para mabasa niya. Dalawang asterisk. 2, x. So, pag i-run natin yan, Yun. Na-integrate na siya yung x squared. So, ginamitan ng addition rule. Naging x cubed over 3 na siya. So, yung susunod natin gagawin is gagamit ng from scipy dot integrate. Nag-i-import tayo ng quad. Import quad. So, unang ilalagay muna natin yung mga given dito. Yung I equals quad na f at yung dalawang x na 0 pati 3. Pero bago ito, kailangan mo natin ma-define yung function. So, def f of x return ito yung function return na x squared. So, dahil hindi nga mabasa, dalawang asterisk ulit yung gagamitin natin. Na. So, para makakuha natin yung tamang sagot dito is kailangan natin i-print I times 0. Okay, 0. So, yung kailangan na lumabas dito is 9. Katulad nung nakuha natin, sinolve natin ng ano. I-run. So, dahil 9 yung lumabas, ibig sabihin tama lang yung pag-integrate natin. At yan lang po yung problem about sa integration.
Good day everyone. So in this part of the video, we will be solving a problem about the ordinary differential equation. So in this part, we will be solving an RL circuit which involves ordinary differential equation to be able to obtain the current of the circuit. So this is the problem. This one is an RL circuit. The problem is related to electrical engineering. So the problem states that a series RL circuit with a resistance of 50 ohms and an inductance of 10 Henry has a constant voltage V of 100 volts. And it is applied at T is equal to 0 by the closing of a switch, which has a initial current of 0. So in this problem, we need to find the current of the given circuit at time t is equal to 0.5 seconds. So first, we are going to solve it manually before we will be using the Jupyter Notebook in programming. So I already made the solution for this problem using the ordinary differential equation. So we all know that the equation in solving for the RL circuit is Ri plus L di over dt is equal to v, in which the R is the resistance of the resistor in the circuit, L is the inductance, while the V is the voltage applied in the RL circuit. So the required differential equation is this one. We just need to substitute the values given from the problem on this equation, and then we now obtain this equation. So the R is equal to 50, the inductance is equal to 10 Henry, and the voltage, which is equal to 100 volts. So after substituting all of the values that are given in the equation of the RL circuit, or the ODE of the RL circuit, we can now manipulate it. We just need to simplify this one. We need to divide both sides of the equation by 1 over by 10, or we can multiply both sides of the equation by 1 over 10. So this 10 will be cancelled. So it will become di over dt. And then the 50i will be divided by 10, so it will become 5i, while the 100, after divided by 10, it will become 10. So after you obtain, or after you simplify the equation of the RL circuit, the next thing that you need to do is to find for the integrating factor of this equation. So the integrating equation, or the integrating factor of the equation, is denoted as u of t. So this one can be obtained with this equation, e raised to integral of p of x dt. So in this equation, the equation of the RL circuit, the P of X can be obtained with the value of the coefficient, or the variable that is being multiplied to the independent or dependent variable, which is I. So the P of X in this equation is 5. So after you identify the P of X, you just need to substitute it into this equation. So this will become e raised to the integral of 5 dt. So after integrating this one, it will become e raised to 5t. Omit this part. You can omit this one, and you can immediately proceed into this part, in which the equation that you need to have to be able to solve the equation of um, the ODE, or the equation that you need to find, you need to have to find the I, is here. So you just need to multiply the dependent variable, which is I, to the integrating factor, which is equal to the value of the right side of the equation of the RL circuit, which is 10 times the integral of the um, integrating factor, and that's it. You can now simplify this one. So just need to be able to obtain this equation again, you just need to multiply the dependent variable to the integrating factor, and then you equate it with the value of v, or the left or the right side of the equation, times the integral of the integrating factor. So if you're going to integrate this one, it will become 10 over 5 e raised to 5t plus c. So just simplify this one. 10 divided by 5 is equal to 2. So now the value of I times e raised to 5t is equal to 2 times e raised to 5t plus c. So As what is stated in the problem, so when t is equal to 0, there is no current. So I0 is equal to 0. That is based on the problem. So you can now substitute um, the initial value in the equation that you obtain here to be able to find the value of C. So you substitute the value of 0 into the t. So it will become, uh, just substitute the value of I is equal to 0 and t is equal to 0. So it will now become 0 times e raised to 5 times 0 is equal to 2 times e raised to 5 times 0 plus c. This one will become 0 because if you multiply any value to 0, it will become 0. So this one will become 2 because e raised to 0 is 1. So you are going to multiply it with 2. It will become 2, and then you just copy the c. So simplifying the equation, it will become c is equal to negative 2. So now you have the value of c, so you can now easily substitute it into this equation. So it will now become this one. So what we are finding here is the current. So what we need to separate on the other side is the I to be able to find the current. So we just need to multiply both sides of the equation by e raised to 5t. So after you are, we have a mistake here. You just need to multiply both sides by e raised to negative 5t. So this one should be negative 5t. So this one will be cancelled. This one will be cancelled as well. So if you would multiply 2 by e raised to negative 5t, it will become 2 raised to negative 5t. So now the equation in finding the current at time t is equal to I, or I is equal to 2 minus 2e raised to negative 5t. So what is being asked in this equation is to find the current in the circuit and which t is equal to 0.5. So now after you have obtained the equation in finding the current, you just need to substitute the value of t. So this will be the equation. So I of 0.5 is equal to 2 minus 2e raised to negative 5 times 0.5. So the current at t is equal to 0.5 is 1.835 or 1.83583. This one is in amperes. So that's it for the manual calculation. Let's now proceed to the Jupyter notebook where we will be making a code to be able to solve this problem. So now let's proceed to solving the problem that we had earlier using the Jupyter notebook or the Python. So here we are now on Jupyter notebook. I already input the problem here with its corresponding circuit. So let's read the problem again. A series RL circuit with R is equal to 50 ohms and with an inductor which has 10 Henry has a constant voltage V of 100 volts that is being applied at T is equal to 0 by the closing of a switch which has an initial current of 0. Find the current of the given circuit at t is equal to 0.5 second. So here, the as we all know, the differential equation are solved in Python with SciPy that integrate package using the function ODE int. So that is a very important function, the ODE int, to be able to find the answer in this problem. So we will be using that later. So I already input the this import, which includes the packages from Python, which will help us solve this problem easier with their respective functions. So the first thing that we need to do is first we need to define the function. So after you have made some import with the different packages with Python, you can now define the function. So we need to use the function def. And then for this one, I want to name this function as def eq, short for differential equation. So our variables are I and t. So our di over dt, or our um, ODE, is equal to n minus 5 times I. This one is obtained from the equation that we had earlier here, the equation of the RL circuit. This one, the di equal to dt plus 5i. You just need to transpose the 5i to the other side, so it will become di over dt is equal to 10 minus 5 times I. So that is what we did here. So the next thing we need to do is to return the di dt function. After you have defined the function, let's now proceed to the initial condition. So based on the problem, the initial condition, which we will denote as IO, is equal to 0. So that's it for the initial condition. The next thing that we need to do is identify the time points of this code. So, or the time points, so time points is equal to t. So this one is the independent variable. This one will be equal to the np. We will be using the numpy function here, the numpy np lin space, which is line space, where we will be going to set the start and in the end of the time points. So I want here that the time point will start at 0 and will end at 0.5, which is what we are finding. Or we can make bigger values here. We can make 1, 2, 3, and so on. And we can add an interval as well, but I just want to make it this values only. After you have determined the time point, you can now solve for the ODE, in which you will be using the ODE int function of the SciPy integrate package. So here, um, what you need, what you are looking for is the variable I. So that is what you need to input here. So it is equal to the ODE integer or int, and then let's input the equation, the function that we made earlier, the def equation, and we can now input the initial condition I I O and T. So the ODE function requires three inputs. So the first one is the function that we made earlier, and the next one is the initial condition, and the last one is the time points that we made. So this one, the model or the function that we made is the function name that returns the derivatives values at requested I and t values, dy dt. So after you have made this code, um, we want to print the value of um, the current at zero point 0.5 second. So to be able to obtain that, we'll be using the numpy function again. We'll be using the np.where function. So what I want to appear here when you print it is um, the value of I at t is equal to 0.5 second is, and then comma, parenthesis. So let's now use the np function, np where t is equal to 5. We need to add some this one square bracket. So we before we will going to plot this equation, we just need to check first if the code that we made will yield the correct answer. So let's see. I'm going to um, check it now. So we had an error here where we weren't able to obtain the value of I at t is equal to 0. The value that was given here not what not what we are expecting. So let's find for the error here. So I am now able to identify the error that we made here. Um, I omitted the I before the opening of the square bracket. So we need to add I here. So let's see. So it is now able to obtain or yield the correct answer, which is 1.83583. So this one is the same to what we had earlier, what we did on the manual calculation. The value of I, or the value of the current at t is equal to zero point 0.5 is equal to 1.83583. So they are the same except for some few values here, or some from few significant digits. So the error is very minimal. So we now able to obtain the current of this circuit. We are now able to obtain the current of this circuit at t is equal to zero point 0.5, which is 1.83583,003 amperes. So this one is the code that we have made. So the problem does not end here. Um, the next thing that we need to do is to plot the graph for this ODE, or for the current of the of, current of the circuit at any time t. So to be able to graph it, this one, I have made a part which we will input the code for the plotting of this. So the import matplotlib.py plot as plt will help us plot the graph of the current is easier with their plotting functions. So the first thing that we need to do is input this code plt.plot t comma I, of course the variables that we have made here. So wait, um next thing that we are going to do is the plot the or the label the x and the y axis of the graph. So for the x axis, I want this one to be labeled as time t, while for the y axis, um, while the y axis will be labeled as current I, or I of t, because it is dependent to the time. So to be able to display the graph, we need to input plt that show, and then that's it. This one is the graph of the current that is flowing on this circuit at time t. So you can see from the initial value that we had earlier that um, the initial current of the circuit is 0 if time t is equal to 0. So if the time t is equal to 0.5, the value is 1.83583. So if you can see that on the graph that we had here, this one, or the zero point 0.5, the current from t is equal to 0.5 is above 1.75. So our graph is correct. The plotting of graph is correct. So we are now able to obtain the current of the RL circuit based from the problem at time t is equal to 0.5 by doing the manual calculation that we had earlier, as well as using the Jupyter notebook with these codes. So that's it for this part of this video. I hope that you are able to understand the coding process as well as the manual process. I hope that you learn something here, and I hope that you will stay tuned and watch the last part of this video, which is the partial differential equation. So that's all. Thank you for watching.
So magandang araw sa inyo. Ngayon isosolve natin tong partial differential equation na to, na heat equation to be exact, na application siya ng PDE, parabolic partial differential equation. Ito, sinagutan ko na to nakaraan sa may performance task 1 ko. So ang tanong is, if alpha is 0.5 square centimeter per second, and the initial temperature of the rod is 50 degrees Celsius, and the rod is divided into 4 equal segments. Determine the temperature of node 2 with a delta T of 0.1 using explicit solution at T is equals to 0.3. So, hanapin daw natin yung temperature ng node 2 at T 0.3 na seconds. So, di natin siya sasagutin gamit yung explicit solution. Sagutan natin siya gamit nung Spider o Jupyter, Python. Python gagamitin natin. So, ito na yung code. Explain ko na lang sa inyo. So, una is i-import mo yung numpy as kung anong gusto mong klaseng pangalan sa kanya. Tapos sunod is matplotlib.pyplot as mp. Ito yung as, kahit ano lang ipangalan mo dyan para lang hindi mo siya isusulat ng buo na kunyari matplotlib.pyplot dot plot. Ito halimbawa dito, imbis na itong buo na to yung susulat mo, mp na lang, mas madali. So, mga given dun sa problem is yung length mo is 12 cm. So, kapag convert natin yung centimeter na yun papuntang meter, makuha natin is 0.12. Tapos yung n mo is 3. So, explain ko sa inyo mamaya kung bakit 3 yung n. Pero sa picture, mabibilang natin 1, 2, 3, 4, 5. So, yung T0 mo naman is, o yung initial temperature mo is 50 degrees Celsius. Tapos ang T1s mo, o yung T1 sa side, dito sa side nito, is 90. Tapos ang T2s mo is 35. So, yung delta x mo naman, o yung difference in distance is yung L over N. Tapos yung alpha mo is 0.001. Tapos ang T final is yung hinanap natin. Itong T final. Ito 0.3. Tapos yung delta T mo is 0.1. So una, ilalagay muna natin tong x is equals to ny o numpy that length space. So yung length space, gumagawa siya ng x-axis. So kumbaga kinokopya natin tong ano na to, plot na to. So kaya siya dx over 2 kasi simula dito sa part na to papunta dito. So dx over 2, yung 0 papuntang 1, ang difference niyan is 1. Yung 1 papuntang 2, difference niyan is 1. So ang dx mo is 1, o yung difference in distance. So simula dito 0 to 1, dx siya. Pero ang kukunin lang natin is itong nasa gitna, kasi yun yung hanapan natin ng temperature. So 0 papunta dito, ibig sabihin kalahati lang siya. So ang labas niyan is dx over 2. Tapos dito naman sa right side, dx over 2, then dx over 2 rin to, diba dapat? Kasi difference dito siya, tapos dito lang kunin. Pero kung dx over 2, dito pa lang yan siya. So ang gagawin natin is itong length na to, i-minus natin siya dito sa dx over 2 nito. Bali dito na lang yung makuha natin sa part na yan. Tapos itong pangatlong number is yung n, yung difference nila. So dito naman sa t is equals to ny that once n times t0. So gagamitin natin siya mamaya Ibig sabihin lang yan is yung t mo is, yung t mo is 50. Tapos itong dt over dt is equals to nymt n. Ito namang time mo is ny, a range, o yung range, alam naman natin yung range. Halimbawa, 0 to 3, 0 to 4. So dito, sa case nito is 0 to t final. Kasi yung hinanap natin is 0 papuntang 0.3. 0.3. Tapos, ang dt mo naman, yung 0.1, ibig sabihin, kapag plinat mo yan, ano siya, 0.1, 0, 0.1, 0.2, 0.3. Ganun mo siya ipa-plot. So, sunod naman is ito ng code. For j in range 1 to length t, ibig sabihin, simula sa 1, papunta ng kung gaano kadami yung t, lahat ng t. Lahat ng, yung simula ay hanggang 0.3. Kasi yun yung, mo yung elements mo. Tapos, sunod is for I in range 1 to n minus 1. So, yung I mo kasi, diba dito yung I? Dito naman is n minus 1. So, ang formula mo is dt over dt or dt over dt. So, kita nyo naman sa side yung formula is equals to alpha times minus ti minus ti minus 1 over dx squared plus ti plus 1 minus ti dx squared. Tapos ito namang part na to is yung boundary mo. So dt over dt simula sa 0, ibig sabihin simula siya dito kasi dito yung boundary mo, diba? So sunod naman is bali papalitan mo lang lahat ng I dito sa part na to, papalitan mo lahat ng I ng 0. So kung ilalagay natin siya dito, magiging 0 minus 1, pero wala namang minus 1 kasi yung minus 1 labas na yun. So ang kukunin mong boundary is yung t1s. So ganun din dito sa susunod is dt times n minus 1 is equals to alpha tn minus 1. Bali lahat ulit ng I dito is papalitan mo ng n minus 1. So ito naman yung magiging sagot mo kasi ang hinanap mo is yung t. So t is equals to t, ito na yung ito, ibig sabihin initial temperature to, tapos plus yung dt, yung sagot mo dito, times yung dt, yung increments, time increments. So sunod is itong mp that figure 1. So pasensya na naputol yung video sa computer kasi hanggang 10 minutes lang pala itong bandicam. Saan ba tayo? Hold din na lang natin mp figure o matplotlib.pyplot. Ibig sabihin lang niya mag-create ka ng bagong figure, kung tatawagin natin siyang figure 1. Tapos ito namang MP dot plot, ibig sabihin ipi-plot mo yung x tsaka ito yung x, tas ito yung y axis. So since yung pagko-compare naman natin is yung distance tapos yung temperature niya doon, so ilalagay lang natin dito is yung x tsaka yung t. Tapos ito naman sunod is yung axis, kung kumbaga ano yung boundary, ano yung mga nakalagay doon sa axis na yun. So dito sa x axis, itong nasa left side is 0 papuntang L. Ang L mo is 0.12. So ang lalabas sa plot natin is dito sa ganyan 0 tapos 0.12 dito sa dulo. Tapos nandito yung mga distance niya sa isa't isa. Sunod naman is itong 0 to 90. Itong 90, pwede nyo siyang baguhin, pwede nyo siyang paliitin. Pero di mo na makikita yung buong graph. So parang ano lang to siya, kung gaano kataas. So since yung T1S natin, yung pinakamataas natin is 90, gawin na lang natin to siyang 100 para mas malaki yung makikita natin sa graph. So kung maliit lang yung nilagay mo, yari 30, ganyan lang siya kaliit. Pero kapag nasa 100, ganito na, katangkad pala. Tapos ito naman mp.x label. So ibig sabihin ang papangalanan mo yung x-axis mo. So in this case, distance yung ipapangalan natin siya. Tapos m, meaning naka-meter siya. So sunod naman is mpy label. So sinasabi ko nga kanina, ang pinagko-compare natin is yung yung distance tsaka yung temperature. So temperature lalagyan natin sa y in degree Celsius, kaya na kasi siya, kasi sa problem is degree Celsius siya. Sunod naman mp show. So ito lang yung magpapakita ng plot mo. Kapag wala ka nito, hindi lalabas yung plot. So try natin tanggalin. Kapag ini-start mo to, walang lumalabas na plot. Ano lang siya, variable explorer. Ayan lang yung plot mo. I mean, hindi siya gagalaw pag walang mp show. I mean yung tama lang, pag walang matplot live.pyplot show. So lagyan natin ulit mp show, tapos mp pause. So itong mp pause is kung gaano lang kabilis mag-create ng bagong mga picture dito, yung pyplot. So kung sabi natin every 1 second, so medyo mabagal siya. Sabi natin 0.01, every 0.01 seconds, mabilis yung pagkakagawa niya. Try natin. Hindi. Tama. So since ano lang siya, 0.3 lang naman yung mabilis lang siya. Halos tatlong tawag dito, picture lang yung lumabas. Pag sinabi natin 60 seconds, ibig sabihin 1 minute natin i-expose sa heat yung both sides. Ganito yung lalabas. Handak na lang natin ito pakita. So yan. Ito yung sinasabi ko kanina, kaya hindi natin sinama yung boundaries. Kaya ang n natin is 3 lang, ibig sabihin yung 3 lang sa gitna. Itong boundary natin hindi na siya kasama. Kaya mapansin niyo sa graph, Hindi umabot na sa boundary natin. Pero kapag habang patagal yan, magiging straight line na yan siya simula 90 dito banda hanggang 35 dito siya banda pag tumagal ng tumagal, kapag umabot na, kasi yun yung parang pinaka principle ng heat equation. Kapag sobrang tagal niya nang na-expose sa parehong sides ng heat, magkakaroon na siya ng equilibrium, kaya straight line na siya. So ngayon is titingnan natin kung tama ba yung sagot natin. Tanggalin muna natin to, stop na natin to. So ang gagawin na lang natin is print mo yung T. So tingnan natin yung lalabas. Ay hindi, naka 60 seconds pa pala yun. 0.3 lang, 0.3. So ito 0.1 to, I mean 0.2, kasi yung 0.1 yun na yung hindi nakasama yung 0. Bali yung sagot is itong nasa part na to, yung 0.3. Ang hinanap is yung node 2. So since yung drawing natin dito is 0, 1, 2, ibig sabihin itong gitna yung titingnan natin kung tugma sa sagot ko. So dito ang sabi is 50.0009. Yung akin naman is 50.0023. So hindi naman siya kalayuan, kasi sigurado ko sa mga sa mga ang tawag dito, mga points, mga decimals, kasi hindi naman natin kinuha lahat ng decimals sa part na to. Pero titingnan natin tong at node 3, 49.832. Halos magkalapit lang din sila dito, di ba? 49.81. Tapos sa node 1 o itong 50.49, 68.75, halos magkalapit lang din sila. So ibig sabihin tama to. Ibig sabihin tama tayo. Ayos. So yun lang naman. Kung gusto niyo makita ko paano ko sinolve yung una, tingnan niyo na lang sa may link sa baba. Ngayon, kung ilalagay ko man dyan. Ilalagay ko talaga yan dyan. So yun lang naman. Salamat sa inyong panonood. Laban lang. God bless sa inyo lahat.